So okay, I'm not gonna even paste anything. So the question is actually simple. So you have an integer array, okay, and then you have some integer k,
Mm-hmm.
and you have to return number of subarrays whose
Mm-hmm.
sum is equal to k. That's
Mm-hmm.
all.
Is equal to k. So can the numbers be negative?
Yeah,
Or
from minus 1000 to 1000.
okay, okay. Um, what we can do? Return number of subarrays whose sum is k. And by saying subarrays, you mean like it should be contiguous, yeah,
That's
without
correct.
gaps. Okay.
So yeah,
Yes.
like
Sum is equal k. Mm-hmm. So it seems like int k.
like for example, let's say here, like
Uh,
what would the output would be for this example, in your
so in this
opinion?
case, it should be two, yeah. First one, one, and the second
Yeah,
one, one. Okay. So the output is two. Output is two. Mm-hmm. And how long can be the array itself?
well, array length, let me give you the length. So it's at least one element
Mm-hmm.
and up to 10 to the power of 4,
Okay.
basically 10,000 elements.
Uh, from
And
one.
k can also be like from minus 10 to the power of
Mm-hmm.
7 to plus 10 to the power of 7.
Mm-hmm.
So k can be negative.
Mm-hmm. 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 Um, what I'm thinking right now, it's some sliding window approach when we have so nums. I do left and right pointer. So and then like I on every iteration I move uh, right pointer and until oh so it can decrease and increase, yeah. Mm-hmm.
Yeah,
The,
that's
pro- the,
correct.
pro- the problem is that, okay, I need exactly like K match and I need to, and
No, there's
I,
no match. You just yeah,
some
yeah,
is
you need
okay.
exact match to the sum.
Mhm.
Yeah, I was thinking you want to look for the length of the array. Okay,
Yeah.
yeah, you need the exact match of the sum equal to k, and elements can be negative. So
So in, so
with
let's
good
say,
example, you will see that
yeah, it seems
uh,
like there are like
sliding window may not work.
yeah, yeah, yeah. It seems like there are like two branches here, like either like I move right pointer or move left pointer, and it's not clear what should I do.
Correct,
So like
because
what I think about like if because like it's branching and like every time I need to branch and it might be like two to the power like I need to like move left right and it's not sure. So what I want to do is oh exactly return sum of those that's equal k. Uh, mhm. So I need to return all the subarrays, number of all those subarrays that have sum equal k.
yeah, just number, not
Yeah,
arrays themselves.
yeah. So I can do kind of prefix sum with a binary search. So I can do like all this. So in this case, we have like say 1, -1, 3, 4, 1, 5 for the array, and then let's say k is equal, let's say 2. Um, so I do the prefix sums. Um, In this case, I do psum is equal 1, 0, plus 3, 3, 7, 8, and then 4, 4, 4, 4, 13. Um, and then uh, for every,
Um,
oh, that's interesting. Like I need to figure out, okay, for every n, for every I, so if I go for every I need to figure out, okay, can I even do the binary search for the left bound? Seems no. Yeah, because like it can
I
change.
think binary search will not help you here. Yeah,
Yeah,
because this
because it's
sum
gonna be
is not
negative.
sorted.
Yeah,
It's not monotonically increasing.
yeah, 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 yeah,
Because of the negative numbers, it may decrease significantly. Like, let's say you have here
yeah. Yeah,
uh,
that's true.
minus 15, and it kills your binary search instantaneously.
Mhm, mhm.
Like, even this -1 kills it actually, because
Yeah,
like you need to go left or right, and then you don't assume that when you go left, do you have higher number than zero here. So
yeah.
yeah,
So brute
binary
force
search will
would
not fly here. Yeah,
what gonna be
let's start with brute force.
brute force. So I need to have left and right bound, left right bound, and like I can uh, check for every right. I can check left bounds, and it's gonna be off and squared, and I can do the prefix sums. So for every left and right bound, I can pre-calculate before I can pre-calculate the prefix sums, and like for let's say I go right goes from one from 0 up to n minus 1, and then left goes from 0 up to right. Um, and then um, and then for this case, for every combination of this left and right, I can calculate the sum that's of elements between right and left. And if the sum is matching the k, I will increment the result by +1. And this is going to be n squared solution. And then it means that, okay, so it means that 10 to the power of 4, so eventually 10 to the power of 8, because we have limitation for the length, maximum 10 to the power of 4. So this is the O(n) squared solution in the time complexity. And the space complexity
Yeah.
of n, space complexity, time complexity of n. So the question is how I can improve that. So like this is not n squared, but something more reasonable. So it's more efficient and not TLE if you have like program to be executed within seconds.
Yeah. Yeah. Well,
So,
let's be clear. It's not like whatever you proposed. It's not actually a brute force, because brute force would be n cube.
mm-hmm, mm-hmm, yeah,
Like you already did improvement with the prefix sum,
mm-hmm,
but yeah, there's like a linear solution. It's up to you. Like it's quite like the code was going to be super simple for linear solution. You
yeah,
will be amazed how simple is it, but I was struggling to come up with this optimal solution. Potentially you may be struggling, so it's up to you. You can
yeah,
implement the code and have something here right now, and then we can discuss, try to find out optimal way,
yeah,
or we can just try to find out optimal way on the
yeah.
spot.
Let's try to find out the optimal way. Um, so the sum, and I'm thinking, can I do the? It's still not ordered, yeah. So I was thinking, okay, if I maintain this window somehow, but it's still again like I need to decide whether I move left and right bound and still, and that's
Yeah,
not.
well, you like I would say like in terms of hinting, I would say don't
I
think
I I
about sorting and
I
windows,
yeah,
sliding window.
I'm thinking about if I can reverse this problem into something like so if a sum if a subarray sum is equal k, I can calculate the total sum. Like total sum should be something like that, total sum of the array. And then the gonna be left part sum plus k plus right part sum. And how to do that? So like, and I need to,
Wait. I lost you a bit. So, left sum and k.
yeah, and this
So,
should,
like each array can be split. Well, like you mean like we can assume that there's something on the left, something on the right, or nothing, and then there's a k
yeah,
subarray which is equal to k. Okay.
yeah, and k and total sum doesn't change. So if I do um, total sum minus k equals left sum plus right sum. So left sum and right is like left sum is like prefix sum, right sum is like suffix sum. And I should think about like how I can figure out how many this like different combinations I can have, like, and calculate them efficiently. So I need to eat the left part and eat the right part so that uh, I feel that it's like something like two sum or something like that problem, two sum problem or some problem.
No.
Like if
Well, it's okay. It's okay. Depends how you solve it. Okay, yeah. There's a way to solve to sum, which is kind of similar. I get what
I
you're
I
saying.
I'm thinking like if I add all the prefixes, let's say I so I do the left sum and then added like frequencies to the left. Let's say we have left sum uh, value 1 and then frequency 1 and then uh, left sum value 2 and then frequency 2 and so on and so forth and frequency 2 and then I do the so it's like let's say prefixes or yeah prefixes and then I do the suffixes and it's gonna be right sum val 1 frequency let's say um, right like p1 and then so on and so forth uh, p2 um, and then so I need to figure out how many uh, so total sum minus k, this is like constant. So I take the value, let's say call it target. So I take the value from the prefixes, left some value, subtract that value from a target. And it's basically the value I should find in the suffixes. And if I find a positive frequency in both, so the question is how much should my result improve? So I have number of combinations fq1 and then let's say call it p and then this one going to be suffix and this is going to be suffix. So it's going to be let's say I found it uh, res fq1 and then multiply by fq s1 and so on and so forth. Let's say we in our case sum plus right sum value going to be equal to the target. In this case, I will go linearly by all prefixes, and I'll do constant lookup for the suffixes and increment the result by this value. Something like
Um,
this.
so wait, we multiplying frequencies.
Yeah, because let's say you have left some to oh, that's the problem because yeah, that's the problem because like they might be overlapping. Yeah, they might be overlapping.
Yeah.
They might be like
Well,
some.
yeah, I would say you're super close. An idea with sum and its frequency is the correct one. actually, and maybe you don't even need suffixes. So you are on the right track here. Yeah, like
Mm-hmm.
you have prefixes, you have their frequencies.
Mm-hmm.
Can you check on the fly if you already met some kind of sums at each point
Yeah, yeah.
and check?
So I can reverse the
Maybe
like
you don't even need suffixes.
yeah, yeah, I don't need that one. So the problem is that I don't understand. So I can like definitely if I have a prefix, um, specific prefix, I wanna know like if I can find let's say for this left sum val1, I can subtract target from target. I can subtract left sum, and I can okay. I need to find the right part, and the right part gonna be the value I need to find, but like I need to show it in a formula based on the prefix, yeah. How I can do that? So if this should be the suffix sum, and I need to have a prefix sum that's kind of complement to the suffix, yeah.
Yeah,
Uh,
it makes sense. Yeah.
so how I can do the complement? So complement should be the total sum total um, sum minus this suffix that I found, target minus left sum, and I should look for the prefix that has this value. And if I find it, I
Yeah,
should.
but you're correct. You're correct, basically. But it's like, well, maybe I'm not understanding totally, like fully what you are trying to say with suffixes, but like, how do you calculate target sum? You go over elements one by one, like total sum of the array, right? You go to the right, for example, then you just add current element. Can you
Mhm,
do this while you are calculating your current total sum? If you have already met something, if you've seen something before, like you add at some prefix at the moment, right?
mhm,
You don't even have prefixes yet. So you are at some like prefix sum right now.
mhm.
Can you check if you have maybe, yeah, I will not give you the formula, but it's really like you have some prefix, you have k. What can you do to do a lookup already in your prefix map?
Okay, so like I have a prefix sum, I have k, so I need to add prefix sum plus k, uh, and then
Why add? Like you are at some
that's
point at
that's gonna be
array,
the prefix sum of the
you
and
have
then
current prefix sum, right? And you have almost like not filled yet completely prefixes map with
Mhm,
frequencies, right?
yeah.
So you can do a lookup maybe there
Oh, you
for
mean
some
like it's
value.
instead of like pre-filling uh, this map of the frequencies, I can do that iteratively. And if I do that iteratively, like as soon as like I discover a new prefix, a new prefix, a new prefix, and by doing this iteratively, I can avoid situation when I have this overlaps, yeah. Because if I pre-calculate these frequencies, I'll have this overlaps, and then like it will
That's correct.
screw up my solution. But if I do that incrementally, I will avoid this overlaps of like of values, and
Yeah,
then
because you're gonna if you fill it in hash map completely, you're gonna have to look up and you're gonna have false positives. You're gonna
yeah,
look in the future.
yeah, yeah, yeah.
That's correct. But if you fill it as you go,
So, so the only problem that I'm kind of trying to figure out, so I have this prefix sum discovered so far, prefix sum,
yeah,
val,
current prefix sum,
val
some
one,
some running
and
sum
then
actually. Yeah.
frequency one. And then I know that there is a k. So I need to figure out if I have a suffix then that ends up somewhere, yeah, that's that should be equal this um, like
Why are you still thinking about suffixes? Like,
because
let's maybe play with example.
yeah,
Let's go lower, maybe, or copy examples here. For
okay,
example, like you have like here this array. Let's try to fill it as you go and look if we can find something here already.
okay,
Like let's try to go over this array and just not use suffixes, just have a hash map and like a frequency of sum, like you proposed.
yeah, yeah. So let's go. So I have this k is equal to say 2, and then say I have like this map initially, and then like I have map initially. Let's say I have one
Empty
and
map.
one.
No, it's empty. Let's consider it's empty, I
Okay,
think.
okay, empty. So I see the prefix one, yeah, prefix sum one. I know that this is the prefix sum. So if I
Yeah, what are you looking for with this prefix sum at this point? Yeah, in the map.
in the
Like
map,
like you have k equal 2 and your current sum is
oh,
equal to 1. What would be your target?
target is sum plus 2, 1 plus 2. So like I should look for the target is 1 plus 2, but I cannot like, but because like I'm building it iteratively, I don't expect it's, okay. So like it's backward looking, yeah? It should be backward
Yeah,
looking.
looking
So I'm
backward.
already discovered, let's say I'm on this point, and I go, okay, this
Yeah,
prefix sum is something,
look back.
and I look back if there is like a tail that's matching my target, because
Okay, yeah,
I was thinking
that's
forward
correct.
looking. Okay, okay.
Okay,
So
now it makes sense. Now I'm confused. I was confused because yeah, the optimal solutions is like in backward looking.
yeah, yeah, yeah.
But yeah, you if you would do like looking like you said, you would have to move from right to left then. It would also work.
Yeah, so like I move, let's say I move from left to right. I have a prefix sum one. I need to look up for the target equals one minus two and equals one minus one. If I find it in a map, it means that okay, uh, there is
Yeah,
and
that's
also
the
I need
last
to
question you need to answer.
on the prefixes I need to store the frequencies, yeah, because like let's say I have
Well,
a
yeah,
couple of
in the map, yeah.
yeah, yeah. So I have like one here. Let's say, yeah. So we have map. So I cannot find it. My map is empty. So I record prefix one, frequency one, and then I go to
Okay.
the I equals one, and then I equals one. The sum in this case gonna be zero. Um, so sum gonna be zero, and I need to look up for the target 0 minus 2. 0 minus 2. So it's gonna be minus 2. Can I find it in the map? No, I cannot find it. So I add 0 and then 1. And then for the I is equal to, I go like prefix is equal 3, target 3 minus 2. And I go, okay, there is one. Can I look in the map? Can I find it? Yes. So I have like one array, so result um, equals one. And I add target 3
Is it
uh,
equals or oh, you just keep this as a
yeah,
variable,
yeah,
but like how do you update the result?
plus equal 1 for the
Yeah,
frequency.
yeah, okay.
3 and then here 1. And then the next one, I is equal 7. So the target I'm gonna be 7. Oh no, I equals 3, target 7. Minus 2 equals 5. I look up in the map for 5, I cannot find it, so I add 7 and then 1. and do that
Yeah, let's
until the
let's try to code it actually because you still have like 4 minutes and we can try to code it. So yeah, it's the optimal way to do it. And
uh,
actually, it's great that you figured it out. Like my question to you is while you're typing, like, did do sum problem remind you of this approach? Like because there's a way to solve the two sum problem where you do look
yeah,
back with
yeah,
hash map.
yeah.
Okay.
To
It's
solve.
amazing because I could not come up with this approach on my own.
Mm.
It's a good sign.
I probably solved it in the past sometime. Import this.
It's wild in the
Okay.
Excel. That's why I decided to ask you this problem. I hate it, but everybody is asking it. It's super frequent problem, and I decided you need to fill this gap.
Okay. So int. So I go um, int. Something like that. I forgot how to do that. It returns int. Okay. Return 0. Will it work? Yeah. Okay. For say n is equal n I, and then for I in range. So we have n, and then we have m is equal, no, let's say called default dictionary, um, import default dic from collection, whatever
Worry
collection.
about the import actually. Let's just finish the logic. Yeah.
Okay, whatever. So
Okay, so there's a drawback from this coder pad because it just keeps complaining about compilation.
yeah, but let's say default dict Python. Uh, where it is? That's basically a lot of distraction while on your real coding interview because like it's complaining and you're distracted. Um, and
Yeah,
like if you don't remember the library, it keeps like these wiggly lines, and like that's might be a deal breaker. Uh,
I agree.
so we have this target. So we need to search for let's say uh, this. Uh, so we have p1 is equal 0, and then I'll do result is equal 0 also, and then I'll do psum equals a plus equal ai, and then I'm gonna check target is equal psum minus k, so we use this k integer, psum minus k, and then um, res plus equal m target, and then return res. And then in the end, we need to update the m target equals m target. Or like I can do the just plus equal one. Um, so we have default dictionary int psum. Did I cover everything? Psum, okay, a plus y target. Oh, we need to add psum here, like psum, uh, plus equal,
Yeah,
something like that.
it's actually the correct one. There's only one edge case with 0.
Uh,
I guess you should put it before even trying to iterate.
oh
Like
yeah.
what I saw, there's the edge case where like you have to add frequency of zero sum and set it to 1 beforehand
Uh,
because you assume that your prefix sum is 0 at the
mhm.
start. So you have zero sum because if you don't do this, you will not pass some test cases. But yeah, it's a
Yeah.
good good problem. I will send you the link and paste it into the document. But yeah, thank you.
Okay.
You did great.
Yeah. Thank you. Hello.
Hi, hi. It looks
Oh,
like we have this just third session, not
okay.
second one.
Hello, Alexei. see.
Oh, hello, hello.
How are you doing?
Uh, I'm doing great. Do you want your coder part or you want
Yeah, let's do the
or you
coder
want?
pod.
Okay,
Um,
then
let's
I probably still have it opened.
Yeah,
Okay,
it's
you
still
give
open,
me
but
another
I
step.
ran out of tokens, so I'm reusing links. I have two free links.
Ah,
So
okay, okay.
let's clean
Yeah,
it
because
up.
I also have I still have this your coder pod opened. So
You
I
you
had
copy
this
I copied
previously.
the whatever like in your doc. I copied whatever you solved, so I'll just remove it. No.
Okay, I will use what you posted in the chat. Okay, no worries. Do you want, I will give you something simple, because I just gave harder task to a previous guy and it was a little bit disaster, too
Okay,
many
okay,
code. And I checked like what you wasn't able to solve before, so yeah, it will be something simple, similar to what you gave me.
okay. Nice.
Uh, and And we can maybe solve it really quick. I'll give you with examples.
Okay, given a string S, return the longest palindromic substring in S. Okay, the first question, the first question I have is like, what's the length of the S? Less S constraints.
You can expect that it would be from exactly one character to
Mm-hmm.
1,000 of characters.
Okay. Um, um, yeah, so the idea is like I treat, so the palindrome can be like something like this. A, like there might be like A, B, A, or like something like when we have in the middle, uh, like I would say even size palindrome, or like odd size palindrome and even size palindrome. When we have in the center like two letters, or like when we have in the center like one letter. And this is case
Yeah.
basically when we have like, um, we can just treat it like this one as kind of edge case, I would say, and start from like
Mhm.
iterating from like say we have um, left I minus one and then I plus one and then right I minus one something like that. So the idea is like I treat the every position as a start for the palindrome, um, and like every index, and they might be, let's say we have B A B A D, and then I'll say okay. I'll think okay if can be like it's the trivial case like one letter is a palindrome, um, and
Mhm.
then like I go this next position K can be I can start from the so there's two types. The first type is odd sized, and the second type
Mhm.
is even size. Um, so for the even sized, I check like the start one is gonna be left, let's say B, right A, and I try to expand it. I cannot expand it, so this and like it's not a palindrome even. BA is not a palindrome, so I proceed. Um, so I do, let's say I have like two branches. First branch for the
Mhm.
odd size palindrome and second one for the even size palindrome. So for the odd size, I go to A and I start from A and try to check like, can I expand it? Yes, I can. So I check left and right, they are matching. So the size changes to, max size changes to 3. And then I try to expand it even further. I cannot, I move it further. I start from B, I try to expand it to ABA. I can. I expand it even further. I cannot. So like max size stays 3. And then like I do for the A and expand it. I cannot expand it. So I stop there and do for D. And like basically for the odd size initial, I can say result is equal 1. And I can consider like starting from index 1 up to n minus 2, not like even consider case D. And for the even size palindrome, I treat like kind of middle index between like 0 and 1 initially, and like I tried to expand it. BA, okay, no, then AB, no, the BA, no, and then AD, no. And I can like save some iterations here because I already know that the max size is 3. So I can start from the, let's say, from AB, yeah, and try to expand it. Because like I can start from the index max size minus 1, something like that, and like try to expand this even sized palindrome, and do this one. So pretty much it. So the time complexity for this one gonna be O of so I consider every position kind of O of n, and then I try to expand it. So it's going to be O of n squared. And then space complexity. So it's just simple global maximum. Yeah, global maximum plus a couple constants. So O of n squared for the time for the space O of 1. Can I improve it? That's a good question, and I think no. um, Yeah, I guess it might be the most optimal way in case of palindrome. I usually for this type of problems I try to think, okay, can I apply DP problem? But like DP will still like give me like n squared, so it's like not much improvement here. Yeah.
Yep, I would say that you're right.
Okay, so I'll start programming. If you find that, I'll have def is.
Yeah, you can start program. Yeah, do you want me to give you again like this class? I can give you like this API as you give me. Yeah.
Okay, that's fine. Okay, so I go. So I have like two cases. The one that's like odd size, and then the one that's even sized. Let's try with the odd size. So say we have max size, or like result is equal 1, and then in the end we return result. And so I go for I in, let's say we cached the size len s, then for I in range 1 up to n minus 1. We go, and now I can even write the internal function def is poly. Zlata, can I do that later? Oh no. Oh, sorry, I have some need to update.
It's
Need to update Roblox on Linux. So my kid can play. Okay.
okay.
So I have this isp function isp internal, and then I have left in index. Oh, like just left integer and then right integer, and I want to generalize it, and then it returns the size. Let's say max p size. And then what I do here, I try to, and then we have like string here. Okay, so I'll try here while left greater than 0 and greater or equal 0, and right less than len s, as I wanna go. So I wanna be. So I check if f L is equal S right. If it's equal, I decrement left and I increment right. And then in the end, I return right minus left plus 1 minus 2. So the
Plus one
size,
minus two, maybe we can
because
somehow
I
minus put minus one.
because I always increment in it and decrement in it, yeah, the size is gonna be r minus l plus 1. That's the size, but it's like forward looking. So like if I have entire string palindrome, it's gonna have minus 1. In the end left gonna be minus 1, and then right gonna be n, yeah, and then the size is gonna be in this case n minus l, so it's gonna be n minus minus what 1 plus 1 minus 2, so it's gonna be what? Plus 1, so
You can just put
plus 1
minus 1.
minus 2, yeah. So I can just do this minus 1. Yep, and then I go for, and then I consider every, let's say, res equals max res, and then I call max p size, and then I call it for the left and right I, and then something like this, and then I check if res equal max, so res, and then I do some overthinking here. So left max p size, I'm gonna be 0, like I minus 1, and then I, and then return res, and then longest palindrome, and then I need to, because I need to cache it also left and right. So I need, and if in case the longest palindrome starts in s, in case I have like competing sizes, what should I do? Should I return the first one? Like, let's say
You should return any of it.
okay. So I should cache it left is equal 1, like left is equal 0, right is equal 0. So it will always give me this one. So we have left and right plus 1. And here, if it's so, if res, let's say res max equals this one, and then if res max greater than res, I'll go what? I go left is equal I. Res max. So it returns the so the left. I need to roll back it, basically roll it back somehow. So I have the size and I have I as a center. So I need to be careful with the indexing here. So it should be I minus res. So let's call it size, just size. And this is gonna be if size is greater than max size, and then I'll call it max size, and then as here, and then max. So we wanna max p size I and I, something like that. Okay, so if size is greater than max size, what I do? So I need to subtract size over 2 from the current one. So let's say we have like current index 1 and the size is equal 2, max size is equal 2. So, and something, I want to do this one, I plus size over 2, but I need to check this all corner cases. So I is the center. So I is the center. Basically, let's say center is like 1, and the size is equals.
Maybe you can think about this case which you mentioned in the description. I mean, like
Yeah.
even and odd cases.
Yeah.
Maybe you can separate this by cases.
Yeah. So let's check this one. So let's say we have A, B, A, and then in this case it will return 3 for the middle index I is equal 1. So I'll go. So in this case I need to left be 0. So I need to I minus. So if I do 3 over 2, it's going to be 1. It's going to be just I size over 2, and then I plus 2. Okay, and then and then I want the size equals, oh, like max size equals size. And then I wanna have this another one in case of like the odd number a b a, and then I check res. So I check again here something like I minus one, and then and then I need to check if again like this, if this is greater than size. So I in this case gonna be so the size is gonna be 4, and then I is equal 3. No, I is equal 2 because I'm checking I minus 1, and then I. So I'm gonna be equals 2, and then left in this case should be size over 2 minus 2. So like size over 2, yeah, so it's the same. So basically the same. Um, and then I need to do s. And yeah, I can move this to the function because it's the same one. Yeah, yeah, the same logic here, but like I doing like I minus 1 here. And then okay, let me do something like Baba and like do like BBA and then check for the, let's say this B. Oh, trying to think like how, what examples I can come up with so this can potentially be broken. Okay, well, simple edge cases. We have string, so it's let's say string size of 1, like even empty. Can it be empty?
Mhm.
And can be probably empty.
It can. I mean, we have at least one character and it will be valid palindrome, so that's do not worry about it.
Okay.
Uh,
If len
I think
s
that
is equal
mhm.
is less than 1, I'll return 0. Um, why is not complaining? What is complaining? Literal is not assignable to sub. I'll return just empty string. Um, I don't know. I feel that I want to play the poker and say, okay, it's gonna be fine.
No. Your logic is absolutely correct. You have just few kind of few bugs, but your logic is absolutely right. You have just few bugs. If you can
Okay.
find these bugs, if not, I can kind of point
No,
you
it's fine.
to
Like
some.
you already gave me many hints. There are some bugs. Okay. Well, so let's. I wanna start with this max p size. So I have int while l is greater than 0 and r is less or equal than size, like this one.
Yeah, that was the first one. Good.
And then lr plus 1. Yeah, r. I was doing there like plus 1, yeah? Plus 1. No,
No, that
missing
was
1.
right.
Still minus.
Yeah, that was right. I did not understood your calculation, although like the final result was right. So you have like
Okay.
right minus L, and in the case of uh yeah, so it should be good.
Up to the range. Range, I wanna
Yeah.
do up to the last, yeah, range up to the n,
Mm-hmm.
and then max p size. So this one, okay, and then left equals size over 2. Um, size over 2, will it work always? So we have, let's say we have something like A, B, C, B, A. So the size is gonna be 5, 5, and then
Mm-hmm.
index say equals 2, 5 over
Yeah, it will work. It will work.
5 over 2, yeah, 0, and then like 2 plus 2, 4. It will work. It works here, and then I wanna do say CC, AA, BB, or like say also CC. So we'll do a. So we'll do -1 minus. So let's say we have I is equal 0, 1, 2, 3, 4, 5. 0, 1, 2, 3. 3. I is equal 3, and then size in this case gonna be 6. Size equals 6. And then I do start with, so I is equal 3, and then 3 minus 6 over 2, 3. So like 0, and then 6, 3 plus 6, well, 3
Mm-hmm.
plus 3, 6, and I'm doing plus 1. So it should be something
Yeah.
-1.
Uh, minus or plus?
Oh yeah, plus, plus,
If
plus,
you,
plus.
uh-huh. Good.
And
This
then,
was just.
yeah.
Mm-hmm.
No, no, wait a second. So like here, I3 plus 3, yeah? So we have 6. And
Yeah. So
this
you
is
have
minus,
even
minus, it's
and
minus.
odd. You have even and odd cases. Yes. You have even and odd cases. How you will how your works in even and odd
Oh,
cases. Yeah. That's the thing.
you mean the
Uh,
size even or odd?
Yeah, size can be
Oh,
can be even or odd.
differentiate.
That's uh-huh.
Okay, okay, okay. So like size, let's say size here 6. And let's say size, let's say 7. Size 7. In this case, let's say we have um, something like, oh no, let's say we add some b in the front. In this case, I is 0, 1, 2, 3, 4. I is 4. I wonder like why I'm doing that. Why I cannot just return left and right, back, and then like don't do that. Playing with backward and forward calculations. I can just return the tuple for the right one
Yeah.
and like do something like this, like left, right, left, and then do this like integer out our like let's say list integer and then like return um, from typing import list, and then I'll do this return uh, left plus one, right, oh, left plus one, right minus one, and then here size gonna be res, and then size equal res 1 minus res 0 plus 1 res, and if size is greater than what, max size, okay, res 1,
Mm-hmm.
what is happening here, res size is
But you're returning then anyway, you're returning not the size, you're returning the palindrome, so your left and right plus one is looks good for me. I feel that you can calculate size on the fly, having just the positions of your
yeah,
start and end of the palindrome.
I'm trying to do that. Let's say res as two asses, res, and then here res. So size is greater than max size, but why it's saying not supported types int and or? Ah, okay. We are returning res. Okay, returning res. What max size? So max size should be integer, and size should be also integer, no? Why this says sometimes it can be a list or integer. Might be, you know, that some kind of corner case, if, I don't know. That's a good question. Okay, something like this, res, and then I wanna do res 0. Oh, I need to save it globally also, max res equals 0, 0, and then max res gonna be res, and then here max res gonna be res, and then here max res 0, and then max res 1 plus 1. Yes, no. Mm, I know. Too much changes. Ah, I know because comma. Um, okay. Something like this.
Mm-hmm.
I can remove left and right here. Um, can we run it?
Yeah, you
uh,
can run. You
main.
have
How
few
does the
minutes.
main? Oh, like let's go test. A longest solution, longest palindrome, and then let's pass. Oh, s equals solution. Then s
Uh,
longest palindrome ABA. And say int t is equal and then what t and then
You
print
can just print this, yeah, print the like whatever.
oh
Run.
no, wait a second, it's send run uh, 96 lines of Python and still running.
And
What? It's
it's
not
done.
ending. What's let's wait a second. Can we do this? Okay.
Yeah, you see left and right. You see left and right, and in your
Uh-huh.
pmax size. Check your pmax size. I also missed it with you. Left -1, right +1. Maybe we should change the direction.
Oh, left why? That's fine. Left -1 and then right +1. So I'm expanding.
You expanded. Yeah, so that's right. Until you have till that's right. Yeah, that's good. Yeah, it's just my bad. Yeah,
No,
then
but
it's good.
I don't know
That's why
why
it's
it's not
running.
why it's not running. How I
It
did
should
that?
at least give us something.
How I did?
A
Ah, wait a
return.
second. So multiple lines, return. Let's say S. Will it
Okay.
run? Oh, it's
Well,
running.
yeah.
So it's somewhere the bug is somewhere inside. Um,
Mm-hmm.
as I so let's call it print F and then left right.
Yeah, and also you see
Minus
-1,
1
3
3 minus 1
return.
3
Right, so
uh, minus 1 3. So that's L plus 1. So I do left and then right and then okay. That's what to print here. Uh, mm, max res 0 max res 1. Oh, it's stucking. It's stopping somewhere.
You also have this max size. You sent 0, 0 there.
Yeah.
So equal to 0 len s. Yeah, so here at this point, I feel that if you already have max size 1, so you should also say like a 0, 1, something like this.
No,
Because
I
you
have
you
like
already like specified
it's
it here,
including.
and you have it 1 here.
Yeah, but I'm trying to like start with you see that with the index 1, so like I don't do like extra checks. Whatever, I'll debug it. Something
Yeah,
is
actually,
not
like,
working great.
just a quick feedback. Everything was fine with all the logic, and you did great in terms of, explaining everything, but you just fallen in weeds, like in
Yeah, yeah,
exactly in the implementation of it. But yeah,
yeah.
I think it was good. It was also fun for me. Okay, then thank you, and
Mm,
you can join the room 3, I think,
yeah.
already.
Well, hello.
Oh, hello. 1 second. Sorry, I thought it should be
Should it be me or
no,
somebody else? Maybe I.
no, it should be Henry.
Ah, okay. Hello.
Hi again. How are you doing?
I'm doing fine. How about you?
I'm great. I'm hungry, but I'm fine. Give me a second. I'll open a
Okay.
task. Do you want me to share it? Yeah, okay, let me check it. So, okay, looks like you didn't provide, maybe you did. No, you didn't provide
No.
a document
Go
in
to this link. Go to the coder path.
CoderPath. Okay, let's go
Yeah,
to
it's on
CoderPath.
the same. I'm reusing
That
the
makes
links.
sense.
I'm reusing the links, so let's do this.
Okay, I have a question. Do you want more difficult or more easier?
I don't know. It's a good question. Um, let's go easy. Let's go easy.
Okay, easy.
Oh
I
no,
ask
no. Let's
everybody.
go difficult. Let's go difficult.
Okay,
I change
because
it.
difficult was specially prepared for you.
No.
And the no, it's just not too much. I mean, like, but I solved 2 tasks before, so I say, okay, this one would be for everybody, but this one would be especially for you. Yeah, for your hand. Okay, let's try this one.
Snapshot
Mm-hmm.
array.
Yep.
That's that looks strangely what I've been asked on Retail AI. Okay. Snapshot.
Yeah.
I'm just snapshot array that supports the following. Okay, implement snapshot array and snapshot with a given length. Initially each element equals 0. Okay. We have array. We have set index and value. Set the element and we have that snap. Take the snapshot of the array and return the snap ID. The total number of times we called snap -1. Okay. Return the value at a given index at a time. This is so strange problem. Okay, so we have setter. Okay, that's fine. We can set the values within the range. Then we have this strange function snap that says how many times we called snap. Um, returns takes a snapshot of the array and returns the snap ID the total number of times. Okay, so it's kind of snapshots the array
Yeah.
and then it records the returns the ID, and then we can get the snapshotted snapshotted change the value of the given index. So we can like giving the snapshot ID we can return the state at a given index. Okay, That's
Yeah.
interesting. What should we do here? So snapshot array develop this data structure. The first iteration is just kind of have this global index or like timestamp, and then um, I update the values at the array. Let's say I have initially 0 and say um, 0. I'll ask that question about the size of this array, but let's and how many times the snap can be called and get can be
Mm.
called.
Okay,
Uh,
so the size of a base array, it could be 5 multiplied by 10 in fourth
mhm, okay,
square. Yeah, so it's like could be a big one. The index could be from 0 till the length that we get from beginning.
okay,
So the length is like it's a length of a given array. I mean, like
yeah,
the yeah, and then the snapshot ID it could be like yeah from 0 till the time we call a snap
mhm,
function snap. Yeah, so
mhm,
it could be as more as you call it, as more as you execute it,
mhm,
the snap ID is going to be like on one less than
okay.
this the amount of the snap called.
And the question is, how many times the snap, the get, and the set can be called?
And between snaps,
No, I mean like how many times like will those functions will be called? Like will they be called like 10,000 times, maybe less number
yep,
of times?
let's call it 10. Yeah, yeah, it could be called in a border from 0 to 10 in
Okay.
10,000 times.
Yeah, 10 to the, oh, 10, okay, 10 to the power of 4 or 5? 4. Yeah.
Let's say 4.
And
Yeah.
like, do they share? Like, can I call uh, so like the total number of calls of this API is like 10 to the power of 4, like they separately 10 to the power of 4, like it doesn't, yeah, it might, okay, that's,
Yeah, yeah, separately.
okay,
Important thing that like let's set up it here for this implementation that between we execute or called snap, we could call set for one index only once.
so we can call set, then snap,
One,
snap,
yeah,
snap, snap, and then like set, and then again snap, so but we cannot do
yeah,
set
for
set.
special index.
Okay, okay,
For we could call set for different indexes,
okay,
but if we talk about one in a border of one index, no, only once.
okay. So we cannot do this set
So
3 and then like set at index like say at set at index 1 set like say 55 and then call set 1 at 3. Can
yeah,
we
we can
can
do
we
it.
do snap in between? Is this valid?
Yes, yeah, of
Okay.
course. Yeah, that's valid.
Okay. So this one is invalid. Okay. So what can be done here? Definitely, I'm thinking about global index for the or global timestamp for the snaps. Yeah, and then I can have this array of arrays logic, and then so let's say we have initially timestamp is 0, and we calling
Mhm.
let's say we have simple array 1, 2, 3, and we populated 1 at 0 index, so 1 gonna have index timestamp 0, and then 2 gonna have timestamp 0, and then 3 gonna have timestamp 0. And then let's say we call snap, yeah, snap. So we increment the index 1, and then let's say timestamp becomes 1, and then I update the I update this array, let's say in called set for the index 0. I want to set, let's say 55. So I'll do this, have this 1, 0, 1 at 0, and then I'll have that another one value, um, 55 at 1, and say all the remaining stays the same, so this double nesting. 2 and
It's
then
for what? Is it for? Okay, I got you.
0. So like whenever we call get at specific index and a snap ID, we should do a binary search. Also, like we can do like we return the whatever, like let's say we call get at index 0, yeah, and
Mm-hmm.
like let's say timestamp, let's say a big one, something happened, say timestamp is like 99. So I do the binary search and I do the first one. I search for the value that has a timestamp less less than this snap ID, less than or like equal. Mm,
Okay.
It should be
Yep. That's
it should be less or equal. Wait a second, I'm thinking like in case like I'm saying 0, it should be equal. The first one that's do the binary search for the first for the value that has a timestamp equal this past snapped ID.
mm-hmm.
So the binary search and then the time complexity, yeah. So set time complexity I inserting to the end. So it's gonna be O for depending on like allocations, etc., etc. It might be, so let's say Python has like efficient one, so accumulated is gonna be O of 1 set, and then the snap the time complexity. So this is all time complexities. Um, so for the snap gonna be also O of 1. We are just incrementing the snap, and then for the
Mm-hmm.
get, it's gonna be O of whatever we have. Um, let's say we do a snapshot, and then we set the same value, and we do again the snapshot, and we set the same value. So in this case, you're gonna just keep increasing the number in the bucket, like keep adding
Mm-hmm.
the values to the bucket, and this is gonna be of like log. So the search gonna be log of n in the worst case.
Mm-hmm.
Uh, so the
What is n in this case?
it's a number we called that's a number of the elements of record in a one bucket, of k. Let's say k is a max length between of buckets, and the
And what
buckets
in
is
our
like
case? Yeah,
what
what the size of a bucket could be.
size of the bucket can be uh, number of number of calls. The maximum size of the bucket gonna be number of calls of the set. Let's say we call set 0, 1, and then we call snapshot. And then we call again set
The number.
0, 2, and then snapshot. Snapshot. Um,
So maybe it would be the number of snapshots.
uh, not not really, because a snapshot. Because like if you do just a snapshot, yeah, it will just increment the timestamp, but it will not modify the this bucket, yeah. So something
Yeah,
like
but
O
we
of like number of calls set plus number of calls snapshot.
Okay, let it be. Yeah. I'm just mean in the worst case, when we calculate a relative, we calculate the worst case.
Mhm.
In the worst case, it would be after every snapshot, we call a set.
Mhm.
So maybe that's like if we talk about relative, we could say that it could be a number of snapshots
Mhm.
or number of the value of our ID, or as you mentioned, of TS.
Mhm.
Yeah, okay, that not matter. Let's jump to space complexity.
Yeah, so the space complexity here. Uh, so let's say we have length. So at least we have length of the elements, and for every length, um, if we call snapshot, 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 it's gonna be a number of, and then set, it's gonna be length multiplied by the snapshot number of like snapshot calls. Um, Number of snapshot calls. So length multiplied by number of snapshot calls. Something like that. So in the worst case scenario, we'll like do linear sets and then we'll call a snapshot and then we do again linear sets. Let's say we set like 0,
Mm-hmm.
index 0, index 1, index 2, index 3, index 4 at like 5 length array, and then we call a snapshot, and then we call again like set for the all kind of indexes, and then we call again
Mm-hmm.
snapshot. In this case, like it's gonna like grow like our like lengths by a number of snapshot calls. Um,
That's right. That's right. Okay. Okay.
I'm
Sounds
thinking
good.
right now, like, is there any better approach than like, can I push it even further instead of like doing this log n, log k for the get? Can I improve it?
Let's try to code it. So as you have 20 more minutes. Let's code it, and then we could jump back and think about
Okay.
more optimal one, because from my perspective, a log k is pretty good one. It's even not a log n,
Mm-hmm.
and yeah, still not a constant, but pretty good one.
Okay. So let's initially we initialize our self data is equal and say we have self timestamp is equal 0. um, okay, yeah, 0, and then self data gonna be empty array multiplied by the length. Oh, like multiply, yeah, empty array multiplied by the length. um, so this is gonna be our buckets for the array indices, like and then for the set. I
You
wanna
know that if you do this one, it would be still empty array.
oh let's do 4 9 okay for I something like
Mhm.
this. Um,
And in the beginning, we have like conditions that initially each element equals to 0.
okay. So initially I wanna insert 0 at the 0 timestamp. Um, yeah, and then what I'm lost there. Okay, yeah, that's it. And then for the setting, I wanna get self data index and then append append this timestamp self timestamp and then value, and then for the snap I want to have self timestamp was equal 1 And then for the get, oh, we need to return to the number of times we called snap, -1, and then return self yes. And here, so here I need to do, say we have a bucket, let's say just a is equal self dot data at index, and then I need to find the first one and do the binary search as I called def binary search. Oh, I can do the binary search right here. So I need to search for the snap ID. I go L is equal -1, right is equal, or like no, something like bad is equal -1, good is equal len A, and then wow, good minus bad greater than 1. I'll do m is equal bad plus 2, and then I check a if a oh if a, so this is a array, and then at the index m, and then I'm getting this timestamp at index 1 if it's
Mhm.
less than,
But it's index 0. You
oh
set
yeah,
up it as
yeah, yeah,
index 0.
index 0. If it's so the question is if it's equal snap ID, I need basically to return the first one that's equals snap ID, or if the snap ID is too big, I need to return uh, the last uh, the last one that's less than snap ID. If it's equal, yeah, something like that. If a is equal snap ID, I just return. It cannot be kind of couple of them like equal in a sequence, so I just return a of m and 1, and then otherwise I'll do mm, if a of m is actually less than snap ID, I gonna move the bad is equal m, else good is equal m, and then I'll return uh, um, a bad 1. Mm,
Try to debug the get one. Okay, let me provide an example. Okay, I'll put it at the end. Let's say, yeah,
okay.
here we have an input, snapshots.
Okay, so let's do this snapshot set at 0. So we have how many? 3 of them. And then we are doing initial like insert. Oh, we do insert. So initially all of them 0, 0. Oh, you mean like, should we do this? So initially 0 and the timestamp is timestamp initially is 0 also. And I'm currently wondering if I should set the timestamp equal -1 for those. How I can decide that? Okay, whatever. Let's think about what happens
Hmm?
for the get. So we do the set at 0, 5. Yeah, let's do that initially -1, and then I'll figure that out later. So we have -1 initially, and then I'm setting at mm, here -1, whatever. So I'm setting 0, 5. So it means that I'm inserting the record like 5, and that timestamp is 0. Um, and then I'm doing snap. So the snap will increase, timestamp becomes 1. And then I'm doing set at 0 index 6, so the timestamp 1. And then get at 0, 0, get the value of the array with the snap id equals 0. So in this case, I will return 5, but I should be returning -1. Should be returning 0. Oh no, that's okay. Snap at okay, yeah. So like if I change it to initially to -1, snap ID -1. So in this case, I should return the 0. Let's debug the get in this case. What's it gonna be? So we have this example somewhere in below. So we have bad is equal -1, and then good. So the A is equal to this array, and the good gonna be equal 0, 1, 2, 3, and then I go while good minus bad greater than 1. Okay, it's greater. M is equal -1 plus 3 plus what? 3 minus -1 over 2. So it's like plus what, 2? Good. Okay, wait. 3 minus -1. So it's gonna be 4 over 2, 2 plus 0. So it's gonna be M is equal 1. And then I check, okay, at index 1, if A at M is equal, so I messed up a little bit here, 5. So I have snapshot at 0 index 1. Yeah, so here it's also 0 and then 5 and then 1 and 6, 1 and 6. And then I have initially -1 snapshot equals 0, and then -1 snapshot equals 0. And then I'll do, okay, here we have 0 snapshot 5 and then 1 snapshot 6, and then middle is 1. I check if A at M0 is equal snap ID. If it's equal, it's actually equal. So M is equal 1, A at 1, 0 is equal 0. Snap ID, given snap ID is 0. So I just return A at M1, so return 5.
Mhm.
Mm, So the case that I was thinking
Okay.
about, like 0, let's say 7, it cannot happen. Why it cannot happen? Because you said that we don't call set for the same
Yep,
index twice between the snapshots. Um,
that's right. Yeah.
so the timestamp snap, I'm feeling that snap is not gonna return me the right timestamp. So it should be number of calls snap -1. So initially I'll change timestamp. So yeah, I just return self timestamp, something like this. What else can happen? Let's say snap ID
Okay.
is super big. Let's say snap ID is equal snap ID is equal, let's say 10. We check middle part. middle part, if it's equal no, snap ID too big, so bad becomes 1, and then good is still stays 3.
Mm-hmm.
Um, and then I go next iteration, so m is equal 1 plus good minus bad 3 minus 1 2 plus 1, so m2, no, yeah, 2, and then I check if a of m2 is equal snap ID. If it's not equal, it's not equal. So I push the bad is equal now 2, and then good is equal 3. We exit and we return the last one. So another
Mm-hmm.
question, what happens if let's say we have really long this array? Let's say snap IDs, it cannot happen like right now, but I'll do that. So snap ID is equals -2. So in this case, the bad index is gonna be very bad. So in case of bad is equal, if bad is equal -1, if it's not equal -1, otherwise, what I'll do? Can it happen first? I feel that because we inserted already the initial values, it cannot, it can never happen. Yeah. So I'll just return bad 1. Yeah. That's fine because we inserted initially like kind of sentinels. Uh, we bad will always end up like with not will always like in case like snap ID is always valid, um, even if the bucket doesn't have like any other values other than the first one, uh, we'll just return like the first one, something like that. Or like if the
Mm-hmm.
snap ID, wait a second, wait, if the snap ID, it still can happen. Let's say we have like a bucket, something like this. Bucket, not index 3, but like at timestamp 3, we have value 1. And let's say at index, timestamp 4, we have in value 5. And say snapshot ID, snapshot, is equal 1. In this case, it can still go bad. So like it's gonna be, oh, and initially it will be have this uh, -1, 0. Oh, so it will go point at this value, yeah, and we will return just 0. Yeah, so Sentinel will protect us against like bad index having like -1 value. Yeah, should I don't know. I cannot find any other bugs other than I mentioned.
That's fine. I mean, like even this one worked, but here, if you do it TS plus one, here you need to return -1. I mean,
Yeah.
TS
Oh
-1.
yeah, yeah. Yes. It's if
This one is like kind of it's correct. Just I don't know why it like have a good, bad, complicated too much, but yeah, obviously there's good ones that works.
have you
So I'll check. Yeah,
what you'll
go ahead.
check start finish feedback and I'll tell you about good bad.
No, that's everything is fine, but you know, like here it's like comparing to other candidates, you definitely know how to solve this question. I mean, like no, they didn't know, and I didn't even ask them. But comparing to them, their issue and their weakness in solving your weakness is to be more confident in your words. You set up it from zero from beginning correctly,
Mm-hmm.
but then you start to, you know, like kind of yeah, you start to because of you think a lot of too much. I mean, I don't know how to solve it because like all of this that you mentioned, it's reasonable, but you
Mm-hmm.
are worrying too much that you know like you're starting to dig in one idea, forgetting about whole one. So
Mm-hmm.
like finish whole one and say, now let's debug. You know, like
Mm-hmm.
so be so let's if we say more in algorithmical voice or like speech, I when you're like telling something to a person, looks like at least me waiting that you're gonna to do in a BFS. So like telling me layer by layer, I understand, but you're working more as a DFS. So like you dive in too much, and like it would be difficult for you to like jump up, and like if it's several layers of diving, it's difficult for you difficult to keep consistency, all of this. So like you solving good, don't worry. Yeah, believe me, I didn't solve it by me, especially I figure out that I didn't solve it with a get correctly from several times. You solve it, but because you start, it's like, okay, play with a -1, -2. If a big snap ID, no condition for big snap ID. Don't worry about big one. Like no reason is 0, 2, 1, yeah, or 1,000. Looks like it works the same, So you could finish and they say, okay, let's debug with this example. If it works bad, fix it. If not, and if interviewer would like to give you some additional like questions, he say, okay, let's imagine we have 100, but before, or 1,000 or 10, before interviewer asks you this, don't push it by itself. So yeah, it just like good. Because I would like, yeah, only kind advice. Yeah, so like no reason to say that you're doing a bad coding. Just just to enhance it. Okay, you wanted to mention something.
Yeah, I think I messed up with the timestamp a little bit. I was thinking like, okay, timestamp initially 0. I insert, so okay, yeah, I increment it and I return like -1. Yeah, that makes sense. I was thinking, okay, -1, -1 plus 1. The bad and good, this is from the, so basically there is a pattern how you can solve any binary search problem with
Yeah, I
the,
know. Usually it's called left and right because you somehow define a boundaries, not like not a logical bad and good, but more like what you have boundary from one side and from other, and just go
binary
there. But it's not. Don't worry. It's like if you're good with it, go ahead with it. Don't worry. Just
Okay, yeah,
it's
yeah.
mostly for people who just starting. For them, it's easier to say start end, left, right, but it good, bad, also fine. You just like
Yeah, yeah, yeah.
conditions, they are all correct, but yeah, you will see, like jumping from one direction to other with this one with debugging. So yeah, everything was pretty good. You say, okay, let's debug it with the examples that I provided.
Mm-hmm.
Do it very straightforward. Say it works mostly in most cases. It looks like I don't know where you are you going planning to apply, but yeah, most cases they say you is fine.
Okay,
Yeah.
makes sense.
Uh,
Thank you. Thank you for
but overall pretty good, yeah, as usual, pretty good, yeah. It's like really nice, yeah, as I see. Did you solve it before?
I so like recently, um, like 2 months ago, like even 1 month ago, I was at Retail AI interview. It's like startup in SF, and like it was screen round, and they give me very similar problem, uh, and it was not based on the array. It was a hash map. You can have a basically the same kind of idea, but instead of like array, it's like hash map and
On the top.
timestamp, and like it should not, yeah. And there was some complication, not a binary search. It was basically they were saying, I don't remember, was it like binary search or something like different that I applied there, but this problem was more like, so you have concurrent structure, data structure. You need to support concurrency. And like this, oh yeah, yeah, yeah. So like hash map with a timestamp.
Got it.
Hash map with timestamp and with a snapshotting. So that snapshotting should be and everything can be called in a parallel, like concurrent environment. And how you can implement
Okay.
snapshotting uh, in a constant time.
Oh, snapshot in a constant time.
Yeah,
Okay.
for the
Okay.
hash map. for the hash map, and like hash map like inserts also for the I guess constant time. I don't remember like if they said like if the get should be also constant time.
Not sure. I'm very not sure. It would
Yeah.
be okay. I have a question, just one. Why here for self data you selected an array, not a hash map? I mean, it doesn't make sense. I mean, like it's this would be the same. Yeah, I'm just wondering because, like, obviously,
Because you
in
underlying it should be like snapshot array, yeah, and I don't wanna like overhead with a hash map.
okay, okay.
Yeah, I wanna like just a constant whatever constant like hash map also constant, but depending on like on your structure. I'm really like trying to remember what they were saying about get. Um should the get be the of n or of of like of one or of log n? I don't remember how I solved that problem. I remember like it was built in a way that I figure out in the last moment that okay, or like somewhere in the middle that I should introduce a timestamp as this variable and
Mhm.
store all records with a timestamp. And oh yeah, and that helped me to deal with this set. Yeah. Oh yeah, yeah. So the problem is like you have a hash map. You have the concurrent environment. You don't even care about get. All you need to do is like do sets and then um, support concurrency, support support concurrency, support instant snapshotting, and support setting. So that
Okay,
later you can pass this structure somewhere, put it on a disk, and like look up later on that one. Yeah, but the snapshotting should
how
be instant. Yeah, and this
how could did you implement the concurrent work with this concurrency?
yeah, I used in Java.
What is oh, you use in Java? How do you use it in a Python? Is it like with some logs or?
Yeah, usually like yeah, it's because like they framed it initially as I thought that like it's a concurrency problem, and I started to solve
Mhm.
like with Java. I wanted to solve that with the Python, but when I heard about that, I was like, oh, I don't know how to do concurrency in Python. That's why I'll switch to Java now, solving in Java, and I just did with a concurrent hash map. I didn't have time to implement get, and they didn't even ask me to implement get because like
Okay,
I was also thinking about like ring buffer, whatever. Uh, was talking about ring buffer there, but yeah, the idea was like pretty similar. Yeah.
okay, and yeah, I'm just wondering. Yeah, so
But I
did they
passed.
ask you for a next step? Did you pass it this interview?
Yeah, it was screening round, and then on interview round, oh, like interview day or something like that. Um, I had